Hi, welcome to clickmyproject.com. Now we are going to study about failure hour resource provision for hybrid cloud infrastructure. Now our basic domain is cloud computing. Cloud computing is a new computing paradigm that delivers IT resources to business and uses a subscription-based virtual and dynamically scalable services in a pay-as-you-go model. Utilization of cloud platforms and services by the scientific and business communities is increasing rapidly, and existing evidences demonstrate performance and monetary cost benefit for both scientific and business communities. In addition to providing a massive scalability, another advantages of cloud computing is that the complexity of managing an IT infrastructure is completely hidden from its user. Generally, cloud computing is classified into private clouds, public clouds, and hybrid clouds. Public clouds provide shared services through large-scale data centers that host a very large number of servers and storage systems. The purpose of public cloud is to sell IT capacity based on open market offerings. Anyone can deploy applications from anywhere on the public cloud and pay only for the services used. Now study about abstract of our main project. In this paper, we propose a flexible and scalable hybrid cloud architecture along the failure hour resource processing policies. Although there are approaches that address how an organization using a private cloud utilizes public cloud resources to improve the performance of its user requests. Existing approaches do not take into account workload type and the resource failures to make a decision about the redirection of the requests. In contrast, our proposed policies take into account the workload model and the failure correlations to redirect resource requests to the appropriate cloud providers. The proposed policies also take advantage of the knowledge-free approach, so they don't need to any statistical information about the failure model. This approach is contrast to knowledge-based techniques where we need specific characteristics of the failure events in the form of statistical model. For instance, discovered the statistical model of failure in a large-scale volunteer computing system and adapted these models for stochastic scheduling of back-of-task jobs. Although knowledge-based technique could be more efficient, they are quite complex and hard to implement. In summary of main contributions in this paper, they are threefold. We provide a flexible and scalable hybrid cloud architecture to solve the problem of resource provisioning for resource requests. In the hybrid cloud architecture, we propose various provisioning policies based on the workload model and failure correlations to fulfill a common quality of service requirement of users' request deadline. We evaluated the proposed policies under realistic workload and failure traces and considered different performance metrics such as deadline violation rate, job slowdown, and performance cost efficiency. The proposed policies take into account the workload model and the failure correlations redirect users' requests to appropriate cloud providers. Using real failure traces and workload model, we evaluate the proposed resource provisioning policy to demonstrate the performance cost as well as performance cost efficiency. Simulation results reveal that is in a realistic working condition while adopting user estimates for the requests in the provisioning policies. We are able to improve the user's quality of service. Next, we have to see DATAFLOW diagram. First we have to start the application. Then we are going to cloud sim configuration. Then clouded initialization part. Then submit data with cloud requests. Forward resource request, then going to private cloud, then we are going to scheduling for backfill scheduling for users tasks, allocate tasks to prior virtual machines. Then if not enough for a virtual machine based upon our users request, going to integrate gateway communication. Then that integrated gateway communication is going to through public cloud. Next, we are going to find out failure hour resources, then allocate task in public cloud. Else, process to next request. Stop our process. Now we are going to see Our project demo, failure aware resource provisioning for hybrid cloud infrastructure. So first form, enter number of data center 1, enter number of users or brokers, the number of virtual machines, enter number of user requests or user applications, now going to assign priority task. 0, 18 and 17 is a priority task. Now scheduling. First you have task priority. Our prioritized task 0, files is 2612. Then 1, 7, files is 4159. And 18, files is 775. Then share out time of our project, each file locations. Then sorting that time. This is sorted priority task. Then get the details of virtual machine manager. Then we have to apply backfilling algorithm. Task load balancing for virtual machines. This is load balance for these virtual machines. 0, 17, 18, 14 is a prioritized to task. Then we have to find out failure model. These are all failure model. Select and choose integrated gateway. These files is access to provide public cloud infrastructure. So we have to gateway, integrated gateway. Already we have create data center, cloud user, virtual machines, user request in public cloud, integrated gateway files. Going to scheduling, DB management, backfilling, overloaded machine. Next we have to task priority, virtual machine manager, execute application task in cloud shell, available virtual machines for private resources. These virtual machines are available. So IgG have to task assigned to public cloud and performance analysis. Performance analysis between time in milliseconds between number of tasks. Thank you for watching this video.